I'm presenting something called a client contract, and it's being developed right now by the Lotus team in collaboration with the CryptoNet lab. So I want to leave like some high-level motivation and I don't know, a description of how you could, who to point to this or how to get involved is like the most important top-level thing, because this might take a while to demo, and yeah, we should get the whole end-to-end picture first. So why would you care about this project? So if you've heard about data DAOs or the notion of implementing perpetual storage on top of Filecoin, then this project is working on a building block which might be of interest to you. It's basically an experimental project trying to make this sort of thing work right now on the FEVM technology that we have deploying later next year. And yeah, we have some prototypes which can do certain things which are interesting from a data DAO perpetual storage perspective. So I'll go a quick overview of the architecture here. So I think everybody here is probably familiar with the idea of a storage deal being initiated by a client, which is a great model and one that Filecoin currently uses. In that case, a client is somebody who's out there on the internet with a public key who's actually making a deal with a provider. The idea behind this project is to try to extend that and think about what we could do making a smart contract be that client. So the very general idea is we have a contract which secures funding in some way and also secures some way to add up a set of CIDs which it's interested in storing, or a reference to data that it's interested in making a deal with. Then the basic model, the storage provider somehow finds out about this and then publishes a storage deal just like it would do today. And then this deal, because of mechanisms introduced as of yesterday in FIP 44, the market actor can call into a general client contract, which can then authenticate the deal or say, no, this deal is no good. And then payments can be handled either through the contract or directly inbound through the market. So you could use like Phil Plus to pay for things too. So that is the basic idea. So making a deal with a contract. Yeah. So with that said, I'm going to try to walk through the basic flow on the basic code. Yeah, and I guess last thing, like before I get into that, we do have one contribution from a community member. More would be super welcome. If anybody's interested in building this sort of stuff, you can point them this way, or if you can leave any comments, questions on issues. Yeah, but I'll get into the code. So I'm still pretty new to Solidity tooling, so you might have to bear with me. On my right-hand terminal over here, I've got some local stuff where I'm actually just munging around Solidity style data and figuring out how to create data which we can use to interact with the contract. And then on the left out here, I have a instance which is syncing Wallaby. So Wallaby, in case you don't know, is the FEVM testnet, which allows you to deploy FEVM contracts right now. And so we can interact with Wallaby directly in this terminal. So what I've done beforehand in order to get ready for this is I've created both the deal client and a mock market on the Wallaby testnet. So to create the deal client, I just took that repo we were looking at and I built this big Solidity bytecode thing to make the contract. And then using the great tooling from the FEVM team, I've created this contract. So there's 3 steps we're going to go through to make to take a look at the end-to-end flow. So the first step, we're going to add in the CID to the client. You can imagine there's many different ways that you could defer this to other contracts or to voting mechanisms or something like that. But for our case, we're going to do the most basic thing and just have a trusted key, add a CID to that client. The next thing we're going to do is make a mock deal. So things are still mocked out a bit because we need to flesh out actually implementing certain parts of the system. So the making the market actually call a user contract needs to happen, and then actually changing the flow of offline deal making to include this flow is something else we're working on. But for now, we're going to have a contract, this mock market contract, which is also deployed right here, which we can send a mock message which says, hey, publish storage deal. And the idea there is that should actually just be a provider who throws the publish storage deal onto chain the way they would now. Okay, and then the last step, we'll check to see that the deal has gone through by looking at the client contract. Again, this is mocked out because we don't have the tools we need yet on Wallaby to actually interact, but that's coming in like a week or two. But okay, so without further ado, I will get started on actually interacting with the contract. So the contract is here at this address. What we want to do is invoke it at its add CID method. So what we can do is run this command right here to create the parameters, which we can then send out to this contract. So Lotus chain invoke. Let's see, so it should be at this address. This is the address that the client contract is at. These are going to be my parameters. And then the last thing is, what is the method we're going to call? We want to call add CID. So that's this method right here from the Solidity tooling. And so, great. Looks like it's going to work because our gas estimation didn't fail. So now we're adding the CID, which the client will say, yeah, I'll make a deal with you on that. So in the meantime, that's going to take a while because Wallaby takes a while. I'm seeing some stuff in the chat. Cool, I can answer some of this stuff later. Hard hat should work. Yeah, Forge is just what I'm using. Just kind of learned Solidity stuff recently. So yeah, definitely willing to try different stuff. But while we're waiting for this to show up, so I have some data here. So what we need to do when a storage provider would create the deal, there would be some tools on their end which would actually create all of this data. But for now, for the purposes of like mocking out this mock market, we're going to send over this already serialized deal, which is Seaborn coded. Basically, this stuff right here is exactly what the market actor sends over to the deal client today during sends over to like account actors today during like authentication of a deal. So this is like exactly the right interface to interact with the market actor that it will send to the client. And this basically is just a thin wrapper around a storage deal. So a storage deal is a few things, but mostly it's this CID here. And this is all in Seaborn bytes, so it's maybe a little inscrutable. But and then there's also this provider here at 66, which will be important later. So we're going to make this deal with the client once the client is ready. So let's see. Yeah, okay, good. So it is executed. The client now has added the CID to its set. And what we can do is create the parameters to send to the mock market. Again, this is what the storage provider would end up doing. So yeah, we need to encode the deal parameters, which are right here. So this is like the deal basically. And then we also need to give it the address of the client. And so let's just go and figure out what that is. I'm getting a little bit lost here. Let's see. So my client is publish mock deal. Yeah, okay. So we added the CID here. The Ethereum address of the client is this guy. Yeah, because we sent to 1434. Great. So we can send that right there. These are the parameters which will make the mock deal. So we're going to go Lotus chain invoke, and the mock market is at T01428. This would really be like the storage market actor, the built-in storage market actor. In the unmocked case, get rid of that OX. I think just double check. Yeah, D75 is the make a deal part. So great. Now we're going to publish that deal. And I see that we're almost going over. I'll keep going unless if somebody tells me to not keep going, I will definitely stop here, but I can try to finish quickly otherwise. So we're waiting for Wallaby to execute this message. Thanks, Misty. So we're waiting for Wallaby to execute this message. And the last thing we're going to do after that is we're going to check to see if the deal was made correctly by inspecting that the provider is listed in the contract. The contract state will tell us what deal has been made. So we're expecting to see provider 66 based on our deal structure right here. Our deal proposal was saying, hey, let's make a, will you make a deal for this CID with provider 66? And so this should be the thing which checks to see, does the Solidity contract have a provider which is storing this CID, and that provider is 66. So we can do this. The only thing that's going to change actually, so I think this should actually be the same bytes. The only thing that's going to change is this is where our contract is right now. Yeah, so hopefully I didn't just hit a raise condition, but the message looked like, the deal looked like it went through. And so now all we have to do is wait to see. If we get a 1, then it means that the provider was added. If we get a 0, then it means that I messed up the demo, but I promise we can make it get to be a 1. Yeah, so we can wait for that a little bit. Yeah, I can also take a look at some of the questions, if there was anything. Nice, okay. Looks like most of the chat was just people talking about stuff. Yeah, this is the problem with dealing with a live network. Things take a little bit of time.
I guess while that's running, do you mind answering like one question I have, or?
Yeah, I'd be quite happy to answer questions. I'm getting pretty bored here.
Yeah, so I was wondering if you have any plans, or did you consider yet integrating with the FEVM Plus program and using this as like the backend for a platform to actually manage the FEVM Plus processes involved and workflows?
Yeah, I think there's a lot of
consider it?
opportunity. Yeah, I've definitely been thinking about that. I think so the thing that our team first wants to build on top of this is some sort of Filecoin state preservation thing. And in order to do that right, we need some sort of incentive to actually pay out for the deal. It seems like Phil Plus is like pretty much the standard right now for doing that. So the hope is to leverage Phil Plus directly. If we can get data cap to this contract, that's kind of the direction we're thinking right now. Of course, you could also pay directly with Filecoin. But yeah, there's other ideas about maybe like making clients very auditable by having all of their behavior specified in a contract, which could be appealing in the future of Phil Plus. So yeah, definitely also open to hear more ideas there. And I guess just heads up, it looks like it worked. We added the provider, and so the deal went through. Again, when this is not mocked out, we'll actually see like the deal in the built-in storage market. But yeah, that's the completion of the demo. So thanks so much for listening, everybody.